And transcript, okay. All right, folks, thank you for working in Alex. I can see most students are doing an awesome job. Let me just mention to you a few housekeeping items before we get started. And so, folks, here's some due dates coming up. So actually 6A and 6B in Alex, these modules are due today, tonight. So that'll be our focus today, is to go through these topics and make sure you're comfortable with those. Then there's a module 7A and 7B due Wednesday and Thursday. We'll cover that today also. And then modules 8A, 8B are coming up towards the end of this week. Folks, remember there's a weekly time goal that's asking you to spend at least 1 hour a day in Alex, so 7 hours total for the week. Folks, that's just a motivator for you to be spending enough time in Alex. That's the key to success. I think you probably know that already, but you know, if you just log in once every couple of days into Alex, you'll fall behind. You will not be successful. Okay? All right, folks, a couple of other reminders. You have tutoring help if you need it. Right, so let me bring that up. As a quick reminder, has anyone tried the tutoring? Let me go find that.
I have inside the Learning Center.
There's two types of tutoring that we have available. One type is online tutoring through Zoom. That's this tutoring I'm showing right now. And so, for example, tonight from 4 p.m. to 9 p.m., if you click this Zoom link, you're connected with these tutors. For example, today, Joanne and Janet will be available. You don't need an appointment. You just pop into this Zoom room. Has anyone tried this tutoring?
No. What time was that?
It's 4 p.m. to 9 p.m. on Sundays, Tuesdays, Wednesdays. Folks, please, if you need a little extra help, these tutors, Joanne and Janet, know Alex very well. They know MATH022 inside and out. And they are very, very patient. They will explain concepts in an easy to understand way. So give this a try if you need help. Besides this tutoring, there's also the Learning Center. So, you know, folks, the reason the college set up this tutoring here is they know students struggle with algebra, especially students coming back to school after, you know, not having taken a math course in a while. And so that's why the college set up this very specialized tutoring for MATH022. Okay? Students that have used this have told me in the past, excellent, excellent tutors. And they told me this tutoring made a difference in their success. And the best part, it's free, totally free. The other tutoring is the Learning Center. And for that, there's either face-to-face or online as well. This is the general Northampton math tutoring that's offered for all math courses. Okay, so whatever option you're interested in, please don't be shy about using the tutoring help. Okay, that's my soapbox speech for today. Folks, before we jump into Alex, does anyone have any general questions on using Alex, on checking your status in the course so far? There's two ways that you can kind of see where you are in the course. One way is you can go into Brightspace. Let me show you in Brightspace. There's two grade books we have, one in Brightspace and one in Alex, and they should be synced together. So if you go here and click on grades, that should show you how you're doing on each one of these modules. And it should also show you your overall weighted average in the course. Another way you could check is if you go into Alex and go to the main menu, it's in the upper left-hand corner, there's a main menu in Alex. One of the drop-down items will be gradebook. And there again, you could see your average to date plus your scores on all the individual modules, okay? All right. Folks, any questions? Is anyone frustrated with Alex? Is anyone enjoying Alex? Maybe enjoy is too strong of a word. Is anyone finding Alex helpful?
I like Alex.
Good. And Talia, can I ask what appeals to you?
I like that they give you like an explanation before each like section, I guess. And I like the little encouraging, like you're on your path kind of thing. Um, it's kind of fun for me.
Good. Excellent. Yeah. Folks, remember there's a lot of built-in help in Alex. So there's those explanations. There's also videos built into Alex. So when you're in an Alex problem, on the right-hand side of the screen, there's a bunch of help buttons. One is a video button. The other is an envelope, which is a message button. If you click that envelope icon, it sends me a message and I can get back to you with some assistance. So please feel free to use that as you need to. All right. Well, folks, let's go to Alex then. And let me come down here. And we want to focus today on 6A and 6B because these are due tonight. So these topics are due tonight. Now, if you scan over these topics, you'll notice the focus here is on something called graphing a line. So we're going to do a lot of graphing today. So let me give you some background on this. And we'll get started. I'm going to ask you to try some examples today, so please have some scrap paper handy. And this module, 6A, 6B, is important because a lot of the other modules are going to rely on this graphic. So let's jump into it. First, why do we want to graph? What's the point of graphing? Well, if you remember in previous modules, let me bring up a blank piece of paper here just to write on. Hold on a second. All right, so if you remember, we were solving equations, which, so we were solving equations. But the equations had one letter. Let me give you an example. X plus 7 equals 10. I'll give you a simple example here. Remember, your goal here was to get X by itself on one side. So what you said to yourself is, all right, to get X by itself, I can get rid of or cancel out that addition of 7. So I'll subtract 7, but you got to do that from both sides of the equation. Adding 7, subtracting 7 canceled out, and you got X equal 3. So you came up with one solution here, or one answer. That's good for scenarios where there's one unknown quantity that you're trying to figure out. But there's many scenarios where there's two unknown quantities that you're trying to figure out. And so what we want to do is have a new kind of equation today. The new equation is going to have two letters in it, not just one. So here's an example. Y equals 3x plus 2. Let me give you a realistic example to give you a sense. Let's say I want to know the value of my car based on its age. So I'm going to give you a quick example here. Negative 500x, we call it the age of the car, plus 2,000, let's say. You know, if you go to the car dealer and you want to trade in your car, and you say to the car dealer, all right, how much is my car worth? The car dealer would say, what is the year? How old is your car? And you would say, well, it's 8 years old. Well, the car dealer would plug that 8 into this kind of an equation and come out with a answer for the value of your car. Because the value depends on the age, right? I think you'd agree. The older your car is, the less it's worth. Well, what we do here is instead of using words like value or age, we replace these with letters. So the way we would rewrite this is y equals negative 500x plus 2,000. So this is an equation with two letters, x and y. We call them variables, right? So it's better to say two variables. The reason we say variables is x and y can vary, right? Where one variable depends on the other. Let me give you one more example here, just to make this a little more concrete. How about if you wanted to calculate your weekly pay at your job? And so your weekly pay depends on how many hours you work. So maybe your weekly pay is 25 times the hours worked plus 50. So what this would mean is you're making $25 per hour, and each week you get a bonus of $50 if you show up on time. But again, we want to use X and Y as letters to make this just more of a shortcut equation. So the way we write this is weekly pay would be represented with Y, hours worked would be X. And if you want to know your weekly pay, just tell me how many hours you worked. I'll plug that in here for X, and I'll get your weekly pay. Well, it turns out for these kinds of equations, let me write this equation again, Y equals 25x plus 50. There's really many solutions to these equations, not just one solution. Because one week you might work 10 hours. If X is 10, then your pay would be 25 times 10, that's 250, plus your $50 weekly bonus, that would be 300. So for this example, X equals 10 and Y equals 300. Let me give you another example. Let's say during a certain week you work 30 hours. X equals 30. What's your weekly pay? Well, I'm going to plug it into this equation. 25 times 30, that's 750 plus 50, that's $800. Here's another solution. X equals 30, Y equals 800. And I can keep doing this over and over. Now, when you get these solutions over here, we write them in a shorthand notation. The way you write a solution is you put the X number first, the Y number second, in parentheses like this, and a comma in between. So my solutions I could write as 10 comma 300, that was one solution. 30 comma 800, that's another solution. I keep going on and on. Well, if you have an equation like this with two variables, there's many solutions, but I don't want to write them all out because there's really an infinite number. So instead of writing out the solutions, we create a graph. So what we're going to see is a graph is really showing you all of the solutions to an equation like y equal 3x plus 7. So that's the whole point of graphing, is to be able to take an equation that has two variables and show all of the infinite solutions, because there's no way to write them all out. You'd be up all night. All right, so that's the background of what we're going to focus on today is how do you find these solutions and how do you create these graphs? Now, when we have an x comma y pair like this, we call this an ordered pair. It's a pair of numbers, and the order matters. You always put the x number first and always put the y number second. An easy way to remember that is x comes before y in the alphabet, so x always has to come first in this parentheses. All right, let's go to Alex. Folks, please ask questions as we're going along. And in Alex, if you remember, I can sort these topics. And it looks like here in Module 6A, I'm seeing that most students have done a good job in 6A. But still, let's do a couple of examples for a few of these topics. Let's just do plotting a point, because that actually I can see 100% of students have that, but let's do it anyway. Quick one. All right. So imagine you have an XY solution and you want to plot it on this graph. So let's talk about this graph setup. The way this graph is set up is there's really two number lines. There's a number line going horizontally that we call the x-axis. 0 in the middle, positive numbers going to the right, negative numbers going to the left. But we superimpose on this a vertical axis that we call the y-axis. And we plot positive numbers going up and negative numbers going down like this. So this is the starting point for our graphing. All right, well, let's say you come up with a solution like 6, negative 4. Remember, this is an ordered pair. The x number is first, the y number is second. How do you plot this point on the graph? So this xy pair is going to plot as a single dot. Well, what you do is you use the first number as the horizontal distance to travel. So the first number 6 is telling you how far to travel horizontally. And by the way, you always start, when you're plotting a point, you always start here at this intersection of the x-axis and y-axis. We call this the origin. It's like the starting point. Well, the first number here is 6. That's telling you to go horizontally 6. So let me go horizontally 6. So I'm going to walk horizontally 6. Now you don't plot anything yet because you still have to move vertically. That's what the second number is telling you. The vertical number here is negative 4. Well, negative 4 means go down 4. So I'm going to turn and go down 4, which would put me right here. So this black dot is the location 6, negative 4. Okay, this is kind of like giving you directions on how to get to my house. I would say to you, go 6 miles east and then go 4 miles south, and this is the location of my house. All right, let's do a few more very quick examples because you've got to be able to plot these points for what's coming up next. And again, folks, if you're not familiar with this, please ask questions about it. Let's do this one. It says 0, 3. Well, the first number is the horizontal distance to go. The second number is the vertical distance to go. Remember, we're always going to start here at the origin. Well, this is telling me go horizontally 0. That means I'm not going to go anywhere horizontally. but then go vertically 3. That just means I go up 3, which is going to put the point right here on the y-axis. Now, how do you actually plot these points in Alex? Let's do that. Let's do an example there. Let's plot it using the pencil. So what this pencil does is it lets you move to a location. So let me click the pencil. And notice now I have a pencil. I'm moving my mouse. All right, this point is 1, -5. That means go horizontally 1, vertically -5. I'm going down 5 now. 1, 2, 3, 4, 5. Click my mouse right there, and Alex puts a dot there, and that's it. I'm done. Okay, so plotting points is going to be the first step in doing this graphing exercise. All right, let's go and talk about, let's set up, let's do a table example here. All right. Well, it turns out when you do the graphing that we're going to focus on, one way to do that is to create an XY table, like they're showing you here. And they're giving us an equation, y equals 5x minus 1. Now, they've already filled in the x column for you, so let me write that. -1, 0, 1, and 2. What they're asking us to do is fill in the y column. Well, I know that y is 5x minus 1. So for each row in this table, I'm going to plug in the x value into this equation and work out the corresponding y value. Let's do this row right here where x is 1. Make it a little easy. So x is 1. Well, that means y is 5 times 1, subtract 5. By the way, folks, remember when you see 5x, it really means the 5 is multiplying the x. You might say, how do you know that? Well, if there's no symbol in between the 5 and the x, multiplication is understood or implied. All right, let me work out this expression. Now, you got to be careful here. There's something called order of operations, because notice here's a multiplication and here's a subtraction. You got to be careful to do the right operation first. Well, there's something called order of operations that says multiplications should be done before any additions or subtractions. So I'm going to do this multiplication 5 times 1. Well, that's 5. So we have 5 subtract 1, that's 4. Now I'm going to add one more column out here just for my own information. I'm going to put the x and the y together in these parentheses. So let me take this row. X was 1, y was 4. So I'm going to write that as 1, 4. All right, let's do another row. Let's do the bottom row, 2. Well, the y value would be 5 times 2, subtract 1. I'm going to do this multiplication first. 5 times 2 is 10. 10 subtract 1 is 9. So this row is going to be 2, 9. I guess we should keep going and just fill in the rest of this table. How about when x is 0? Y is 5 times 0, subtract 1. But 5 times 0 is 0. Remember, any number times 0 is always 0. That's 0, subtract 1. Well, that's a -1. So this row is 0, -1. Last example up here, y is 5 times -1, subtract 1. 5 times -1 is a -5. -5, subtract 1. Anyone have a comment? How do you think about -5, subtract 1? How would you work that out in your head? Sometimes students get a little confused with this kind of a subtraction.
I think about it as like someone taking like another dollar out of your bank account or something like that.
Good.
So like if your balance is -5 and you buy something for $1, it'll go to like -6.
Excellent. So, yeah, very good. That's a good way to think about it. -5 is like the starting balance in your checking account. If you subtract 1, it's like you wrote out a check at the store. So your balance is -5. You wrote out a check, that's going to knock your balance down. So that's going to make it -6. Good. So this is -1, -6. Well, the way to answer this question is all I have to do is pop in the y values here in this column. So I would type in -6, -1, 4, and 9, and that would be it for this example. But let me take this one more step, because when we get to another topic, they're going to ask you to graph this equation. So let's pretend like this problem said, graph the equation y equals 5x minus 1. All right, here's how we could do it. 1, create an XY table. We just did that. Now, really, we just need 2 rows in this table. I know we have 4 rows in this table, but we only really need 2 rows. Why only 2 rows? Well, it turns out in order to graph a straight line, you need at least 2 points. 2 points would uniquely determine a line. All right, here's what we're going to do. Plot each XY point. I'm going to say plot each XY solution as a dot. Step 4, connect the 2 dots with a straight line. That's it. So let's do it for this example. How about if we pick, let's pick the last 2 rows. So I'm going to use these 2 points. So I'm going to use, I'm going to plot these 2 points. All right, let me do it here. This will be kind of crude, but here's the x-axis, here's the y-axis. 1, 2, 3. -1, -2, -3. Here's the y-axis. 1, 2, and I'm gonna pretend 2, 3. Here's 4, 5, 6, 7, 8. Here's 9. All right, let's go plot it. The first one is 1, 4. Well, for 1, 4, you go horizontally 1, vertically 4. So I'm going to go horizontally 1 and vertically 4. And I'm going to put a red dot there. All right, let me plot the second point. The second point is 2, 9. So I'm going to go horizontally 2, vertically 9. Horizontally 2, vertically 9, puts it right here. Now I just connect these 2 dots with a straight line. So let me get a straight line here. Here's my fancy straight line. Connect these 2 points with a straight line. There it is. That straight line is the graph we're looking for. Now you might say, well, you picked the last 2 rows in this table. What if we picked the first 2 rows in the table? Well, it turns out you can pick any rows you feel like. You're always going to end up with the same line. Let's see that just to confirm that. Let me go and let's plot the first row. The first row is -1. That's going to be the horizontal distance. And -6, that's the vertical distance. All right, I'm going to estimate this. And my graph was not that well drawn. So that's a problem. I'm going to have to redraw my graph because I did it so sloppily. Don't tell anyone I did it that sloppily. Not good. Let me redraw it. What I'm trying to show here is that all 4 of these XY points align on the same straight line. So let me do a better job of graphing here. The problem is I got to kind of keep the scales the same. 1, 2, 3, 4. -1, -2. 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's go down 1, 2, 3, 4, 5, 6. -6. Okay. Let's plot each one of these 4 points. Let's do -1, -6. All right, I'm going to start here at the origin, go horizontally -1, vertically -6. That puts that point there. All right, let's plot 0, -1. Well, 0, -1 means go horizontally nowhere, but then go vertically -1, which would put me right here. All right, 1, 4, we already plotted, but I'll plot it again. Where's 4? 4 is like here, I guess. So 1, 4 would be like right here. And 2, 9 would be up here. Do you notice how all 4 of these points are really aligned on the same straight line? Pretend these are all lining up on the same line. So what it means is you can pick any 2 rows you feel like, and you'll end up with the same line as another student that selected 2 other rows to plot. All right, so anyway, these are the steps that we can use to do some of this graphing. We can create an XY table like we just did. Really, you don't have to create 4 rows. You can only create 2 rows. That's a little shortcut. For each one of the 2 rows, plot the XY solution as a dot or a point, connect the 2 points, and that's it, you're done. Now, Alex is going to make it easy because Alex is going to give you a graphing tool to graph these. So I'll show you that in a second, okay? Folks, let's do one more example here. We'll take a quick break. Folks, any questions so far? All right, let's go to some topics down here that I think were causing a little more trouble. Let's do this one. It says finding a solution. All right. So this one says find, let me get an example that's a little easier for us to start with. All right, let's take a look at this one. It says find an XY solution to this equation. 4x plus y equals 9. Well, what I'm really looking for is a replacement number for x and a replacement number for y that would work in this equation, meaning it would yield or result in a true equation. Well, here's what I could do. I can pick x to be any number I feel like. Pick any number for x. Now, do I really mean any number? Yes, you could pick any number you want. You could pick x equals 10, x equals 2, x equal -7, x equals 0, x equal 3.45. But we want to keep this as simple as possible. So I'm going to pick an easy number to work with. I'm going to pick x equals 0. Picking x equals 0 is a good choice because really that makes the arithmetic as simple as possible. So if I pick x equals 0, that's step 1. Step 2 is plug in the x value in the equation and solve for y, meaning get y by itself. Well, I'm going to replace this x with a 0. But 4 times 0 is 0. Remember, any number times 0 is 0. So that's 0. 0 plus y equals 9. But 0 plus y really stays as a y, right? If you add 0 to any quantity, it doesn't change the quantity, right? 0 plus 10 is 10. So 0 plus y is y, so y equals 9. Well, that's it. I have y by itself. Let me put it together. X was 0. Y was 9, so the ordered pair they want is 0, comma 9. Now, one important item here is when you go to enter this in Alex, Alex already put the parentheses for you. So you're not going to enter parentheses in your answer. You're just going to enter 0, comma 9 in the blue boxes. And you don't even need the comma. Remember, the comma is there for you. So really, you're just going to be typing in 0 in the first box, 9 in the second. But what if you picked x equals 2? Let's do x equal 2. So pick x equal 2. Remember, you can pick x to be any number you feel like. Well, here's the equation. I'm going to replace x with a 2. 4 times 2 is 8. Whoops, there should be a 9 here. Sorry. 4 times 2 is 8, so that's 8 plus y equals 9. But I want to get y by itself here. So let me subtract 8 from both sides of this equation, because that'll cancel out this 8 here on the left side. So we have y equals 9 subtract 8 is a 1, y equals 1. Well, if I put this together, I have x equal 2, y equals 1. In an ordered pair, it's going to be 2, comma 1. So there's many, many correct answers to this problem, right? Because each student can come up with a different answer, and we can all really have correct solutions. Folks, any questions on this example? Let's do one more, and I promise we'll take a break in a second. But let's do one more to finish up Module 6A. Let's do this bottom one. That seems to be causing the most trouble. It says, find the x and y intercepts of a line. Well, what does that really mean? And how are we going to answer this question? Well, when we go to do some graphing in a little bit, we're going to end up with graphs where the lines might do something like this, let's say. A line might go uphill like that, or you could even have a line going downhill like that. And so what an x-intercept is the point, so an x-intercept is that point on the graph where the graph intercepts or crosses the x-axis. Well, on my graph, this here, this is the point where the graph is crossing the x-axis. So this would be the x-intercept. Let me just label this as -2 here, just as an example. Well, the x-intercept then here would be -2, comma 0. Because if I started here at the origin to get to that red dot, I would go horizontally -2, but then vertically nowhere. So if I'm not going up or down, I'm just staying on the x-axis. That means the y value would be 0. All right, what about the y-intercept? Well, the y-intercept is that point on the graph where the graph crosses the y-axis. I'm going to use the word intercept to make it clear that that's what intercepts mean, where the graph intercepts the y-axis. Intercepts means cross. Well, that would be this blue dot here. That's where the graph is crossing the y-axis. Let me just make something up here. I'll call this 0, comma 3, because this is at a height of 3. So in this case, it'd be 0, comma 3. Why 0, comma 3? Well, if I start here at the origin, to get to that blue dot, I would go nowhere horizontally, but then I would go up 3 vertically to get to the blue dot. If I come down here to this example, down my graph on the bottom of the screen here, this point here would be the y-intercept. And this point here would be the x-intercept. Let me label these points just as examples. I'm just kind of making up these points, but let me just label this point. This is, let's say, 5, 0. And this point here on the y-intercept, I'm going to label as, let's say, 0, 6. And this point here was negative 2, 0. All right. You might say, okay, that's good, but for this Alex problem, they didn't give us a graph. So how do you figure out the x and y intercepts if you're not looking at a graph? Well, here's what you could do. You can make use, let's talk about the x-intercept first. To find the x-intercept. So this is when you are given an equation like this. Well, here's what I'm noticing. This x-intercept is negative 2, 0. Do you notice the y value is 0 here? Let me come down here. The x-intercept is 5, 0. Do you notice the y value is 0 for this example? Well, it turns out for any x-intercept, the y value is always 0. Does that make sense? Why is the y value always 0? Well, if you have a point on the x-axis, let me draw a couple of random points on the x-axis. Here's a point, here's a point, here's a point, here's a point. Let me label these. So this was negative 2, 0. This is 3, 0. This is 5, 0. This is 7, 0. Do you notice in the examples I just worked out, the y value is always 0? Why is that? What's the reasoning for the y value to always be 0 here? Anyone have a comment on that?
I think it's because like the line has to intercept with the x-axis, so it has to be like on a zero, like the when you when you said to plot the line in the middle where the zero lies, I think the y intercept stays on that line. I think
Yeah. Yeah, Denzel, right. An x-intercept is a point on the x-axis. So if you notice, these green dots are all sitting on the x-axis, which of course is a requirement for an x-intercept. An x-intercept is going to be a point on the x-axis. But if you think about a point on the x-axis, it has no height. There's no vertical distance for any of these green dots. That's why the y value is 0, because you didn't move anywhere vertically for these green dots. You just stayed on the x-axis. Well, anyway, what we're going to do then is take the equation and set y equal to 0 in the equation and solve for x. So let's do it. We have x subtract 2y equals negative 6. But we're going to set y equals 0 because that's a requirement for an x-intercept. So I'm going to replace this y with a 0. But 2 times 0 is 0, so this is going to be x minus 0 equals negative 6. But x subtract 0 stays x, right? If you subtract 0 from a number, it doesn't change the number. So that's just going to be x equals negative 6. Well, that's the answer to this x-intercept question at negative 6. All right, let's go and find the y-intercept. Well, let me draw a few examples of y-intercepts so you can get an idea of the setup here. So for a y-intercept, it has to be a point on the y-axis. Let me just make up a few points on the y-axis here. This point would be 0, negative 1 down here. This point would be 0, 3. This point is 0, comma 4. This point is 0, comma 6, etc. Do you notice anything in common for these red dots that are sitting on the y-axis here?
The x-axis is 0 for all of them.
Exactly. Good, Yvonne. Yeah. The x value here is 0. Notice 0, 0, 0, 0. That makes sense because the x value is telling you how far to go horizontally. But all these red dots are sitting on the y-axis, which means you're not traveling anywhere horizontally. So to find the y-intercept, we'll make use of the fact that the x value is always 0. For any y-intercept, the x value is 0. So that means set x equal to 0. So let me go to the equation. It was x minus 2y equals negative 6, but we're going to set x equal to 0. So that's going to be 0 subtract 2y equals negative 6. Well, 0 subtract 2y stays negative 2y. So let me finish it up here. Negative 2y equals negative 6. I want to get y by itself in this equation. It's being multiplied by negative 2. So to get rid of that multiplication of negative 2, I'll divide by negative 2. But you got to do the same operation to both sides. This negative 2 on top cancels out with the negative 2 on the bottom. That leaves me just y. On the right side, anyone remember what is a negative divided by a negative?
Positive.
Positive. And that means y equals positive 3. So that's the answer for the y-intercept positive 3. Okay, folks, so when they talk about an x-intercept, what it really means is where the point on the x-axis where the graph crosses the x-axis, the y-intercept, that has to be a point on the y-axis where the graph crosses the y-axis. But if they don't give you the graph, you can use the equation, and to find the x-intercept, you set the y value equal to 0. To find the y-intercept, you set x equals 0. You could think of it as when you want to find an intercept, you set the other letter equal to 0. So to find an x-intercept, set y equal to 0. All right. Folks, how about if we do this? I want to ask you to try one of these. How about if we take a break and I'm going to ask you to try, let's say this example. This a little bigger so you can see. So why don't we take a break? We'll get another cup of coffee. How about if we resume at, let's say, 8:55? Take a 5-minute break. Okay, please give this a try. And I'll just give a quick reminder here to find the x-intercept. You set y equal to 0 and find the y-intercept. You set x equal to 0 in the equation, okay? All right, folks, let's take a 5-minute break and then we'll come back and work this one together. All right, folks, should we take a look at this one? Anyone have a comment or proposed solution on this one? So it looks like a bunch of folks put results in the chat. Looking good. All right, let's do it. So let's find the x-intercept by setting y equal to 0 in this equation. So let's do it. 4x minus 2y equals 4. We're going to set y equal to 0. So this y gets replaced with a 0. But 2 times 0 is 0. 4x subtracts 0. If you subtract 0, that doesn't really change a number. So that's 4x equals 4. Divide both sides by 4 because I want to get x by itself. X equals 1. So that is the x-intercept, 1. All right, let's turn to the y-intercept. Write the equation again. But now we're going to set x equals 0 in this equation. So I'm going to replace this x with a 0. 4 times 0, that's 0. Now I got to be a little careful. This is 0 subtract 2y. Let me give you an example to help illustrate that one. How about if we had 0 subtract 7, let's say? Well, one way I could think about this is 0 is the starting balance in my checking account. My balance is 0. But I wrote a check for $7 to the store. You know, when you subtract 7, it's like you wrote a check out. Well, if you start with 0 as your balance and write a check out for $7, your negative 7 is your balance. So 0 subtract y is going to stay negative 2y. To get y by itself, I'm going to divide both sides by negative 2. So y equals, well, here we got a positive divided by negative. Positive divided by negative, the answer is negative, so negative 2. So y equals negative 2. All right, good work, folks. Now, one thing I could do here, they're not asking me to graph this, but if I wanted to sketch a graph of this, I could, because I know the x and y intercepts. Let me do it quickly here. Let me mark the x-intercept. The x-intercept is x equal 1. Remember, the x-intercept has to be a point on the x-axis. So I'm going to come over here to 1 and put a red dot. That's the x-intercept. Let me plot the y-intercept. Remember, the y-intercept has to be a point on the y-axis. So y equal negative 2, that would be down here somewhere. So this blue dot is the y-intercept. Well, these are 2 points that fall on the line. So if they asked me to graph the line, I could connect these 2 dots with a straight line, and that would be the graph of the line. And it turns out later, this is one way to graph a line. You know, if they said to you, graph 4x minus 2y equal 4. One option to you is to find the x and y intercepts like we just did, plot the x and y intercepts, and connect them with a straight line. All right. Folks, any questions on 6A? Anyone have a topic here on 6A that's causing trouble or you want to go over? All right, let's go to 6B. And so 6B is really going to ask us to do graphing. So let's do a couple of examples here. In fact, why don't we do this one down here? It says graphing a line by first finding x and y intercepts, because this is similar to what we just did a second ago. So let's take a look at this one. All right. So it says the equation of the line is x plus 5y equals 5. And it says find the x-intercepts, y-intercepts. Let me write this equation over here so we have it. X plus 5y equals 5. All right, so there's going to be two parts to this problem. Let's call it part A. And then part B, they're going to ask us to actually create the graph on this XY graph. Well, let's find the X and Y intercepts first, like we just did. So let's find the X-intercept. Well, for that, you let Y equals 0 in the equation. So let's do it. X plus 5Y equals 5, but I'm going to let this Y get replaced with a 0. 5 times 0 is 0. X plus 0, that stays X. Right? If you add 0 to any number, you don't change the number, so that's X equals 5. So the X-intercept is 5. Remember, that's going to be a point on the X-axis. If you wanted to, I could write it as 5, 0. You might say, how'd you get 5, 0? Well, we just figured out that the X value was 5. And we started out assuming that Y was 0. So that's how I was able to write this XY pair. All right, let's find the Y-intercept. For that, you let X equal 0. So let me go back to the starting equation. But now I'm going to let this X equal 0. Well, 0 plus 5y, when you add 0 to any quantity, you don't change the quantity. It stays the same. So that's just going to be 5y. Get y by itself. I'll divide both sides by 5. And so it looks like y equals 1. So the y-intercept is 1. If I wanted to, I could write that as the x value is 0 here. The y value is 1. So I could write this as 0, 1 if I want. All right, let's go to part B. Part B is the graphing part. Well, let me plot these 2 points, and I'll connect them with a straight line, and then I'll show you how to use the Alex graphing tool. So let's plot the x-intercept at x equal 5. Well, that means go to the x-axis and go to 5. 5 is right here on the x-axis, and put a dot there. Let's plot the y-intercept. The y-intercept is 1. That means go to the y-axis and put a dot at 1. That would be right here. I'm going to connect these 2 points with a straight line. It would do something like this. And that's the answer that Alex is looking for. So what we did here is we plotted the x-intercept as a point on the x-axis. Then we plotted the y-intercept as a point on the y-axis. And then you connect the 2 points with a straight line. But how do you do this in Alex? Well, the easiest way to do this in Alex, let me erase my line here, is to use what they call the line tool. And this icon right here is called the line tool. And notice it shows as a line with 2 points on it. So I'm going to click on that with my mouse. So let me click on it. All right, now I could see Alex is saying plot the first point. Now what I'm going to do is move my mouse to the first point, the first dot I want to plot, and click my mouse. That locks it in. Let's plot the x-intercept. That was 5. So I'm going to come here to the y-axis, and I'm coming here to 5 right there. I'm going to click my mouse. Do you notice Alex put a red X? And now Alex is saying plot a second point. Well, I'm going to plot the y-intercept, which is on the y-axis at a height of 1. So I'm going to come up here right there. That's the y-intercept. I'm going to click my mouse again. And Alex drew this blue line through the 2 points. And that's it. So really, all you have to do to graph a line in Alex is click the 2 points that you want to plot, and Alex draws the line for you. So you don't have to actually draw the straight line. Alex will do that for you. I'm going to come down here and say check. Let me type in 5 and 1 up here just to complete this. And I'll come here and say check. And Alex says correct. The graph looks good. Folks, any questions on how we did this graphing? So I think this line tool, this line icon over here is the easiest way to do the graphing. All right, let's go back to 6B. Anyone have a topic here in 6B that they would like to jump to?
Whatever the one is that says fraction.
Fractional slope. Yeah. Let's do that one. Yvonne, before we do that, let me do a little bit of a simpler example here for graphing. All right. So let me explain. Let me get a better example to start with here. Let's do this one. So it says here, graph the equation y equals negative 3x. All right, now, when you're graphing, you have two options. One option, I'll call it option A. You can make up an XY table. We did an example like that earlier. But there's another option, I'll call it option B. It says use something called slope and y-intercept. Let's do that in a little bit. Let's use the XY table because this is a pretty simple equation. It's just y equal negative 3x. All right, well, what you do is you make up your own little XY table like this. Let me actually make a little more room here for this. And really, I just need 2 rows in this table. So I'm just going to set up 2 rows. All right. For the X column, I can pick X to be any numbers I want. So for these X numbers, I'm going to pick any number I feel like. Now I could pick X equal 10. I could pick X equal negative 17. But I want to make the arithmetic as simple as possible. So I want to pick the easiest numbers for X to work with. The easiest numbers are going to be 0 and 1. But you can pick any numbers you feel like. But I think 0 and 1 are good choices because they make the arithmetic as easy as possible. What we have to do now is figure out the corresponding y value where y is equal to negative 3x. Let's go to the first row. Y equals negative 3 times x, but the x value here is 0. But negative 3 times 0 is 0. So let me put the xy pair in this last column here. Well, in the first row, the x value is 0, the y value is 0. So that's 0, comma 0. Let's do it for the second row. The second row, x is 1. So y is going to be negative 3 times 1, which is negative 3. Let me put those together. The x value is 1. the y value is -3. All right, so that's step 1, make up this XY table. Step 2, plot each XY solution as a point on the graph. Once we do that, we'll just connect the 2 points with a straight line. But Alex will do that for us. All right, let's do it. Let's plot 0, 0. Well, that's an easy point to plot, because if you start here at the origin, you go horizontally nowhere, you go vertically nowhere, that means you're really just staying right at this point. So I'm going to put a red dot here. This red dot is 0, 0. All right, let's plot 1, -3. Well, the horizontal distance is 1. The vertical distance is -3. So I'm going to go horizontally 1, vertically -3. It would put me right here. Connect these points with a straight line, and that would be the graph that Alex is asking me for. Let me use the line tool here in Alex so that you can see how to do this in Alex. Let me scroll down a little bit. All right, let me click here on this line button. All right, it says plot the first point. Well, our first point is 0, 0. That's right there. So I'm clicking my mouse. Now Alex says place a second point. Well, I'm going to go over 1, down 3. 1, 2, 3. Click my mouse. There's the answer. So when you have a equation that's easy to work with, like y equal -3x, making up an XY table is kind of a good option. All right, let me go to another topic and let's look at a different way to graph these equations. So sometimes there's a better way to do the graphing. And what we do is we make use of something called slope, and y-intercept. Well, you know about y-intercept, right? Y-intercept is the point on the y-axis that the graph crosses. I'll say the graph intercepts on the y-axis. That's the y-intercept. But we didn't talk yet about slope. What is slope? Well, slope is a number that measures the steepness of a line. Let me give you a quick example here. Let's say we have a line that's going uphill like this. Well, this slope is a number. I'm going to make up a number 3. But what if I had a line that was steeper? Let's say this red line. This red line is steeper. Well, the slope here would be a bigger number. The slope here is 7. Let me do one more. How about a line that's really steep like this? Well, this slope is an even bigger number. Let's say the slope here is 12. But of course, we could also have a line that goes downhill. A line that goes downhill is going to have a negative number as the slope. So any downhill line, like this purple line, its slope is negative. That tells you, the negative tells you the line is going downhill. So this slope might be something like -4, let's say. Well, how do you figure out the slope of a line? We'll talk about that in a little bit. We're going to come to that. But for right now, how do you use slope to help you do the graphing? Well, let me give you a little background here, and let me use this example to kind of walk through the steps. All right, now, first thing is when you write the slope of a line, let's say the slope was 3. We use the letter M to indicate slope. So when you see the letter M, it means slope. When it comes to y-intercept, we use the letter B. Let's say this y-intercept is -8, for example. B is the letter used to indicate a y-intercept. You might say, where did they come up with these letters from? And it's a good idea maybe to jot this down, this notation, so you can remember it. The y-intercept being labeled as B kind of comes from statistics. And the slope being labeled as M, I think comes from the French word for mountain. So I think the M stands for mountain. Anyway, here's what we could do. When you see an equation like y equal 3x plus 8, there is a way to write this equation in what's called slope-intercept format. And it looks like this. Y equals m times x plus b. In this equation, the m stands for slope, and the b stands for the y-intercept. What that means is if you have an equation like y equals, let me make something up here, 5x plus 9, you can instantly know the slope of this line and the y-intercept without really doing any calculations. All you have to do is compare your equation to the template y equals mx plus b. And now I just do a matching. Well, the slope is whatever numbers multiplying the x. So in my example here, the slope is 5. So slope m equals 5. The y-intercept is this b number in the back here, so our y-intercept is 9 in this example. So you take the equation they give you and compare it or match it up to the famous y equals mx plus b. That'll let you match up the slope right away. That's the m value, and match up the y-intercept. That's the b. Let me stop here for a second and see if that's okay, because this y equals mx plus b equation is probably one of the most important concepts from our course. You're going to use this y equal mx plus b over and over. Okay, so this is called slope-intercept form. You can see why it's called that, because it's giving you the slope m and the y-intercept all in one nice little package here. All right, well, let's go and take our equation. Let me take our equation here. So let me get rid of this. And I'm going to compare our equation to figure out the slope and y-intercept. So our equation was y equals 3x subtract 8. Can anyone comment? What is the slope and y-intercept in this example? Y equal 3x minus 8.
3.
Yep, and that 3 is the
Slope.
slope. Good.
Yeah.
So m is matching up to 3. Good. So the slope is 3. Good. And the y-intercept?
That will be minus 8.
Negative 8.
That'll
Good.
be, yeah.
Yeah, Lily said negative 8 also. Good. Three answered negative. So B is negative 8. Okay, good. So that's really the first step to doing the graphing, is figuring out the slope and y-intercept. The way you do it is take the equation they give you and compare it to y equal mx plus b. And again, folks, this is an important equation to write down somewhere. Some students like to tattoo this on different parts of their body. I can't require you to tattoo this on your arm. I got into trouble last semester by requiring tattoo. The dean says I can't do that. They're so old-fashioned at Northampton. But anyway, you might say, well, okay, what do you do now? We know the slope and the y-intercept, but they want us to graph. So let me erase some of this stuff here for a second. And I want to write down a definition for slope. When you have a slope, is really the vertical change divided by a horizontal change. Let me explain what I mean by this. Let's say I had a line that went uphill like this. And let me just mark 2 points like this. All right, so I'm going to mark 2 points like this. And let me ask myself, what is the vertical change between these 2 points here? So I want to know, like, what is this vertical distance? I'm just going to make something up. Let's say this vertical distance is 8. The other thing I want to know is, what is the horizontal distance between these 2 points? This would be the horizontal distance. I'm just going to make up something. Let's say the horizontal distance between these 2 red dots is 4. Well, the slope of this line, the vertical change in my example was 8. The horizontal change was 4. 8 divided by 4 is 2. So this is one way to calculate the slope of a line. Pick any 2 points on the line, figure out the vertical spacing between those 2 points, figure out the horizontal spacing, take the vertical change divided by the horizontal change. That answer is the slope. All right, well, let's go and do the graphing finally for this example. Here's how we're going to do it. Step 1. Plot a point at the y-intercept, because you know the graph has to go through the y-intercept, so we might as well plot a point. Let's do it. B is -8. Our y-intercept is -8. So I'm going to come down here to -8 on the y-axis and put a blue dot. That is the y-intercept. I know the graph has to go through that. Step 2, use the slope as instructions on how to plot. Let me get rid of some of this stuff here. Use the slope as instructions on how to plot a second point. Because remember, you need 2 points to create a line. Well, here's what we're going to do. Take the slope. In our case, m is 3. Now, we really want the slope to look like a fraction. Because remember, slope is vertical change over horizontal change. So I want to take 3 and write it as a fraction. Well, anytime you have a whole number, you can always write it as the whole number over 1 to turn it into a fraction. So the slope I'm going to write is 3 over 1. Why did I write it that way? Well, the number on top 3 is the vertical change, or the vertical distance to go. The number on the bottom 1 is the horizontal change. So really what the slope is telling me when I have 3 over 1, this is going to tell me go up 3 and go over to the right 1. These are the instructions on how to plot a second point. So I'm going to go to the y-intercept and follow these instructions. The y-intercept is telling me go up 3. All right, excuse me, I'm using the slope now. The slope is giving me the instructions on how to get to the second point. So let me go up 3. 1, 2, 3. I just went up 3. Now I'm going to go over to the right 1. Here I am going over to the right 1. And now I'm going to put a red dot there. Now, last step, of course, is just connect the points with a straight line. And so our line would look something like this. By the way, here's a little sanity check. Do you remember that a line that goes uphill, so if you have an uphill line, it must have a positive slope. If you have a downhill line, it must have a negative slope. Our slope was 3. That's a positive 3. That's telling us our line has to go uphill. If I messed up somehow and ended up graphing a downhill line, I would immediately know that's wrong because a downhill line has a negative slope, but our slope was positive. All right, let me do this. Let me stop here for a second, actually. Folks, let me recap, and we'll do a bunch of examples here. So when you're graphing a line, an option is to use what's called the slope-intercept form. That means use y equals mx plus b. That will give you the slope and y-intercept of the line immediately without any real calculations. Once you know the slope and y-intercept, the first thing to do is go and plot a point at the y-intercept. Then use the slope as instructions on how to plot a second point. The number on the top of the slope is telling you like the vertical distance to move. The number on the bottom of the slope is telling you the horizontal distance. All right, well, let me do this using the line tool in Alex. So let me erase this and let's do the line tool. All right, I'm going to come over here and click on this line tool. All right, I'm going to the y-intercept of -8. So I'm coming down here to -8. I'm clicking my mouse. All right, I'm ready to plot the second point using the slope. So I'm going to go up 3. 1, 2, 3. Over to the right 1. Click my mouse again, and there is the answer to this question. Folks, any questions on these steps?
My question would be going back to the slope being like in this like fraction form. I just don't understand how we got the horizontal changes 1. Like, where does the 1 come from? Is it
Yes.
always 1?
Well, good question, Yvonne. Let's talk about that. So in this example, we started out with y equal 3x minus 8. And we said, let's compare this to the famous y equal mx plus b. Well, this m is the slope here. So we said m is 3. But we want the slope to be in a fraction. This is the one time where you really want to work with fractions. Why do you want the slope to be a fraction? Well, because we want to write the slope as like a vertical change over horizontal. So we want the slope to be in a fraction. But our slope is the whole number 3. It turns out anytime you have a whole number like 3, you're allowed to put 3, the whole number, over 1.
Gotcha. Thank you.
So for example, if we had the number 12, I could write that as 12 over 1 if I feel like. Any whole number can be changed into a fraction by putting the whole number over 1. How about -7? I could write it as -7 over 1 if I feel like. All right, well, why don't we go and do an example with fractions in it? So let's go to that other topic, which said graphing a line with a fractional slope. So let's do this one. All right, get one that's a little better here. Hang on a second. I'm looking for a positive slope to start with. Then we'll do a negative slope. Oh boy. Well, let's do this one, I guess. All right. So here's what I'm going to do. Let me write the steps. Steps to graph using slope-intercept form. All right, step 1. Compare the equation they give you to y equal mx plus b. Write down the slope m and the y-intercept, which is b. Let's do that. So they're giving us the equation here. Y equals 1 over 5x subtract 3. I'm going to compare this to y equals mx plus b. Well, the slope is whatever number is sitting in front of multiplying the x. So our slope here is 1 over 5. How about the y-intercept? Well, that's this b number back here. Well, it's matching up to -3 for us. So our y-intercept here is b equal -3. All right, let me go to step 2. Plot a point at the y-intercept. Well, that's easy. Right, our y-intercept is -3. Let me scroll down here a little bit to plot that point. So let's go ahead and plot a point at the y-intercept -3. That's down here. All right, let's go to step 3. This is the tricky step. Use the slope as instructions on how to plot a second point. Well, I got to remember that slope is vertical change over horizontal change. Our slope m is 1 over 5. So the number on top, this 1, is telling me how far to go up. So it's telling me go up 1. The number on the bottom is the horizontal change. That's a 5. That's telling us go over to the right 5. Let's do it. I'm going to get the graphing tool. Let me get the graphing tool here. I'm going to go plot the y-intercept, which is -3. So I'm going to come down here to -3 and put a point here. I'm clicking my mouse. All right, it's time to use the slope. Our slope was 1 over 5. That really means go up 1. I'm going up 1, go over to the right 5. 1, 2, 3, 4, 5. Oops. Click my mouse. There is the line that we want to graph.
Okay, so the slope, you don't start it at the origin. You started at the y-intercept.
Good. Let me make a note of that. You're exactly right, Yvonne. You started the y-intercept. So start at the y-intercept. And use the slope as instructions on how to get to the second point. Yep. Folks, let's do another example here, and then we'll take a break, and I'm going to let you try some of these. But let me go and do one that has a negative fraction in front. I shouldn't have erased those steps. Oh, that's okay. Whoops. All right, let's get another example, but let's make it negative. All right, let's do this one. So here's the equation they're giving us. Y equals negative 3 over 4x minus 1. Now, before we get started here, I have a suggestion. Here's my suggestion to make things easier. Anytime you see a negative sign in front of a fraction, like in this example, move the negative sign and associate it with the top number. We call it the numerator. Here's what I mean. Take this negative and associate it with the 3 on top. So I'm going to really write this equation as negative 3 over 4x minus 1. That's just going to make it a lot easier to deal with slope. Let me say that one more time. If you have a negative sign in front of a fraction, you're allowed to move that negative sign and place it with the top number of the fraction. That's always a good idea. All right, let's do our steps then. Step 1, compare this equation to the famous y equals mx plus b. Well, I'm seeing here our slope is negative 3 over 4. Our y-intercept is negative 1. All right, let's do our steps. So I'm going to plot a point at the y-intercept, which is negative 1. So I'm going to put a point right here. Starting at the y-intercept, use the slope as instructions to plot a second point. All right, let me examine the slope. Our slope is negative 3 over 4. Well, if you remember, the top number is the vertical distance, but it's negative 3. A negative 3 means instead of going up 3, I'm going to go down 3. So this is really telling me go down 3. The bottom number 4 is the horizontal distance to travel. So this is telling me go to the right 4. All right, those are my instructions. So let me go down 3, starting here at the y-intercept. 1, 2, 3. I just went down 3. Now I got to go over to the right 4. 1, 2, 3, 4. I went over 4. Here is my second point. Connect these points with a straight line. There is my answer. Let me do a quick sanity check. I'm noticing in this example, the slope was negative, right? It was negative 3 over 4. If a slope of a line is negative, it tells you the line has to be a downhill line. Is our graph showing us a downhill line? Yes. If our graph was showing an uphill line, I would know something is not making sense. That would tell me I must have messed up somewhere. Folks, any questions on this step? This takes practice. So you got to go in and try a bunch of these examples to kind of see these steps in action. Folks, why don't we take a break here, and I'm going to let you try one. So let me get another example here. Let's do one with a negative slope, I guess. We get one that's a little better. Let's do this one. Yeah. So y equal negative. Now I'm going to put the negative sign associated with the top number 2 like this. All right. Folks, why don't we take a 5 or so minute break? Maybe you can try this yourself on scrap paper. And we'll come back and do it together. Okay? So why don't we come back at, let's say, 9:50, and then we'll try to finish up this module 6B. All right, let's take a quick break.
Last thing she said is, I have to go to work again.
All right, folks, should we take a look at this one? Before we get started here, anyone have a comment? Are you expecting your answer to be an uphill line or a downhill line for this graph? It's good to know that ahead of time. Well, why don't we do step one? Step one is, let's compare this equation they gave us to y equal mx plus b. Well, if I compare the slope m, it's matching up to negative 2/3. If I compare the y-intercept, that's the b, it's matching up to negative 3. All right, let's go and plot a point at the y-intercept. So I'm going to come here to the y-axis down to negative 3 and put this black dot. So that's the y-intercept. All right, it says starting at the y-intercept, use the slope to plot a second point. Well, our slope is negative 2/3. The top number, negative 2, is telling you the vertical distance to travel. But because it's negative, it means go down. So I'm going to go down 2. So down 2, down 2. The bottom number is the horizontal distance. Our bottom number is 3. That means go over to the right 3. So I'm going to go over to the right 3, put this other dot there, and here is my line. Because our slope was negative, I knew ahead of time that this should be a downhill line. And it turned out it did graph as a downhill line. If my graph was showing an uphill line, I would know that I messed up somewhere. Folks, any questions on any of these steps? Again, this is something you got to practice, but once you get the hang of this, it makes the graphing pretty quick. Okay? All right. Folks, what other... let's do this one. It says graphing a vertical or horizontal line. This one's a little different. All right. Well, what I could do here, so this one says graph the line x equal 4. Well, this is weird because usually the equations have 2 letters in them, right? We're expecting an equation like, y equals 5x plus 2, but this equation only has x in it, so that's weird. But let's use the xy table method to graph. If you remember, you set up an xy table. You need just 2 rows. All right, now, usually we pick x to be any number you feel like. But if you notice here, this equation is telling you x equals 4. That's really telling you the x value has to be forced to be a 4. So I have to put a 4 in the x column for both rows. That's what it means when the equation says x equals 4. You're forced to put a 4 for the x values. What about the y values? Well, this equation doesn't have y in it at all. That means I can pick y to be any values I want. So I can pick y to be any number. All right, I'm going to pick 2 and 7. I just made you say, where those numbers come from? I just picked these numbers to be any values I want. You could pick any numbers you feel like. You could use 0 and 1. You could use 3 and -4, whatever you feel like. Well, let's write the xy pairs. For the first row, it's 4, 2. For the second row, it's 4, 7. Well, let's go plot these. I'm going to start. I'm going to use the line tool. All right, 4, 2. Go horizontally 4, vertically 2. Click my mouse. The second point is 4, 7. I'm going to go horizontally 4 again, vertically 7. That puts me up there. Well, if you notice, this line is a vertical line, straight up and down. So it turns out anytime you graph an equation that looks like x equals a number, like x equals some number. So this might be x equal 4, x equal 9, x equal -2, x equal 3, etc. The graph will always be a vertical line. That just means a line going straight up and down. So I think the best way to handle this is make up your own XY table with 2 rows. If they give you x equal 4, you must fill in the x values as 4. That's what the equation is telling you. X is forced to be a 4. Any questions on that one? Well, let's do another example. So this one says y equals -8. Anyone have a suggestion what you might do to get started on this one? Well, I'm going to make one of those XY tables again. So here's an XY table with 2 rows in it. If the equation is y equal -8, what do you think that's telling you to do to get started filling in this table? Well, if the equation is y equal -8, that's forcing the y values to be -8. So I have to put a -8 here, a -8 there. What about the x values? Well, the x values, I can pick any values I want. Pick any numbers. I'll pick 1 and 3. You can pick any numbers you want. Let me write these xy pairs then. The first row is 1, -8. The second row is 3, -8. All right, let me go plot these 2 points and see what happens. I'll use the line tool again. All right, 1, -8. Start here at the origin. Go horizontally 1, vertically -8. That would put the first point there. The second point is 3, -8. So I'm going to start at the origin, go horizontally 3, down -8. That's going to put me right there. Click, and there is my answer. Well, if you notice, this line is a horizontal line, meaning going straight across. And it turns out any graph that looks like y equals a number will, I should say, any equation, y equals a number, will always graph as a horizontal line. Okay? So folks, for this topic, I think making up your own little XY table is a good idea. All right. Folks, why don't we jump into Module 7? We're going to talk more about slope here, Module 7, 7A and 7B, similar on slope, okay? Folks, remember, please ask about any topic you're having trouble with. We can definitely kind of jump around. All right. How about if they ask us to, let's do this one. It says graph a line through a given point with a given slope. This is going to be very similar to what we've been doing up till now. So let's take a look here. All right. So it says here, graph a line that has a slope of 2, and it passes through this point 4, -5. Well, we've been doing something similar where we started out graphing the y-intercept and then using the slope as instructions on how to plot a second point. We can do the same setup here. Here's what we're going to do. 1, plot a point at the given location, which is 4, -5. Because they're telling us the line passes through that point, so we might as well plot that point to get started. Step 2, starting at this point, so starting at 4, -5, use the slope as instructions to plot a second point. Well, our slope here is 2. So let me write that as m equals 2. But if you remember, I really want slope to be in a fraction form because I want to write it as vertical over horizontal change. Well, any whole number 2 can always be put over a 1 to make it a fraction. So I'm going to write 2 as 2 over 1. Well, if you remember, the top number is the vertical distance to go. The bottom number is the horizontal distance to go. That's the way slope is set up, vertical over horizontal. So for our example, this is telling us go up 2. And that's what the slope on top is. The numerator is telling us go up 2. And the bottom is telling us go over to the right 1. So let's do these 2 steps. Let me start out with step 1. Plot a point at 4, -5. Let me use the line tool here to make it easy. All right, I'm starting at the origin. 4 comma -5. That means go horizontally 4. And now turn and go vertically -5. That means go down 5. So that is the point right there. All right, let me go to step 2. Step 2 says use the slope. The slope is telling me go up 2. So I'm going up 2, 1, 2. Go over to the right 1. Click. There is my line. Folks, any question here? So they're giving you a point to begin with, so you might as well plot that point to get started. The slope is instructions on how to plot a second point. Okay? All right. Yeah, Lily, I saw your note about parallel versus perpendicular lines. Let's do that one in a minute. Let me go back for a second and just do... how about... if we do this one, let me see what's this one. Class slopes. Is this positive, negative? Yeah. All right, we might as well do this one because this one is kind of a visual question. All right. Now, when you are looking at a line, there's 4 possibilities of what the line could look like. You could either have a line that's heading uphill like this, or you could have a line that's going downhill like this. A line that goes downhill has a negative slope. I'm just going to make up an example. This slope might be -7, let's say. A line that's going uphill has a positive slope. I'm going to say here m equals 9, let's say. But there's another possibility. You could have a horizontal line, let's say like this, and you can also have a vertical line that might look like this. Let me try to do it. You might have a vertical line that goes like this. Well, it turns out for a horizontal line, the slope is always 0. That kind of makes sense if you think about it, because slope is measuring how steep a line is. But if a line is horizontal, that means it's flat. It really has no steepness. So the slope is 0. What about this vertical line down here? Well, it turns out for a vertical line, the slope is undefined, meaning there really is no slope to talk about. We'll explain more about how this comes about, but these are the 4 kinds of lines that you're going to come across in this example. So all we have to do is look at the shape of the line and we'll figure out the slope. Let's go to line 1 here. Well, I could see this is a downhill line. Downhill line has a negative slope. Let me go to line 4. Well, this line is uphill. An uphill line has a positive slope. Let's go to line 3. Well, line 3 is a horizontal line. But a horizontal line has 0 slope. And last one, line 2 here, this is a vertical line. And a vertical line is slope is undefined. Okay, you might want to jot these down on a summary sheet of some kind to help you kind of remember these 4 scenarios. All right. Folks, let's do calculating slope, because one thing you might ask is, how do you actually calculate the slope of a line? Well, one thing you could do here is use the definition of slope. So slope is vertical change over horizontal change. So what I can ask myself is, if I start at this blue dot and I want to travel to this blue dot, how far would I go vertically and how far would I go horizontally? Now, one thing I'm going to do ahead of time as a sanity check is I'm going to ask myself, should my answer for slope for this example be a positive number or a negative number? Does anyone have a comment? Do you think this answer should be positive or negative? Yep, Michael says positive. Yep, a reminder, an uphill line has a positive slope and a downhill line always has a negative slope. You know, it's good to know that ahead of time. This way, it's like a sanity check. Our line's going uphill. Our answer better be a positive answer. If I end up with a negative answer, it tells me I messed up something. All right, well, let me ask myself, I'm going to travel from this blue dot on the left to this blue dot on the right. How far would you have to go vertically to get there? Well, I can imagine going up like this and then over like that to do this traveling. Well, let me count. How far did I go up? I went up 2 spaces, so I went up 2. How far did I go over? Let me count. 1, 2, 3, 4. So I went over 4. So our vertical change was going up 2. That means positive 2. Going over to the right 4. So our slope here, m, is 2 over 4. Notice it turned out to be a positive value, which is what I was expecting. Now, sometimes when you enter an answer like this in ALEKS, it says, your answer is correct, but you should simplify fractions. So how do you simplify a fraction? You might remember this from, if you took MATH022. How do you simplify fractions? Well, you look for some number that can evenly divide into both the top and the bottom. So I'm looking for some common number that can divide into both 2 and 4. Well, the number 2 evenly divides into both 2 and 4. So I'm going to divide the top by 2 and got to do the same thing on the bottom, divide the bottom by 2. On the top, 2 divided by 2, that's 1. On the bottom, 4 divided by 2 is 2. So our answer here should be 1/2 as the slope. Now, what if you decided to take a different route? Instead of this red route, what if you decided to go this green route? You went over first and then went up. Well, it's really the same thing. You're going over 4 and you're going up 2. So you would still end up with the same slope, 2 over 4. I like to go vertically first because that's the way the fraction is set up, with vertical on top. Let's do another example where maybe the line is going downhill. Let's do one of those. All right, let's take a look at this one because this one is a downhill line. All right, so I'm just going to use the definition of slope. that says vertical change over horizontal change. So I'm going to start at this blue dot and ask myself, how do I get to this blue dot? Well, I'm going to go down this much and then walk over to the right that much. So let me just count the vertical change to begin with. All right, I'm going down 1, 2, 3, 4. So I just went down 4. Well, when you go down in a downward direction, that's considered negative. So this is going to be -4 on top. Let me count going over to the right. 1, 2, 3, 4, 5, 6, 7, 8. So I just went over 8. So that's going to put an 8 on the bottom. And of course, I want to simplify the fraction. So let me divide top and bottom by 4, because 4 evenly divides top and bottom. So on the top, -4 divided by 4, that's -1. 8 divided by 4 is a 2, so -1/2 is the answer here. Now, when you write your answer in ALEKS, you can either put the negative sign associated with the 1 on the top like that, or if you want to put the negative sign in front of the whole fraction like this, you could do it. Either one of these answers are equally okay.
Can I ask a question?
Yeah.
Why don't we get -8 for the denominator?
The reason we don't get -8 on the bottom, Denzel, is we're going over to the right when we're doing this traveling. When I move to the right, this is a positive direction on the x-axis. If I was moving to the left, that would be considered a negative horizontal.
Okay. Thank you.
Let me do a sanity check on my answer. My answer turned out to be a negative slope. Is that what I was expecting? Yes, it's a downhill line. My answer better be negative. If my answer was not negative, I would flag it and say, wait, something is not right here. The slope of a downhill line should always be a negative number. Now, Denzel, to follow up on your question, I think it's always a good idea to start with the leftmost point and end with the rightmost point, like I did here. Because then you're always traveling to the right horizontally. That would make the number on the bottom always positive, like +8. Because if you're traveling from left to right, like we did, if you're going to the right, it's a positive horizontal distance. The y, the vertical distance, could be positive or negative, right? If you're traveling upwards, that's a positive vertical distance. But if you're moving downwards, that's a negative vertical distance.
Gotcha.
All right, let me show you one other slope calculation, and maybe we can take another break in just a second. But let's come to this one. It says finding the slope given 2 points on a line. Well, this example is asking me to find slope again, but they're not giving me the graph. Now, I could create my own graph, but that's extra work. It turns out that there's a formula for slope that you can plug into. This way you don't need the graph. Let me do this though. Let me just quickly sketch a graph here just so I can get an idea what this line looks like. I just want to know here, is this an uphill line or a downhill line? Because then that would tell me if my answer should be a positive number or a negative number. So let me just graph this. -4, -4. So I'm going to go horizontally -4 and then vertically -4. That would put me down here. All right, how about 2, 5? I would go over 2 and up 5. That would put me up here somewhere. Well, I could see this line is an uphill line. That means my answer better turn out to be a positive number. If my answer turns out to be negative, I know I messed up somewhere. All right, well, how do you do it? Well, there's a slope formula. Here's what the slope formula says. If you want to know the slope of a line, work out this fraction, y sub 2 subtract y sub 1 over x sub 2 minus x sub 1. What does this mean? Well, you go to the 2 points they gave you and label them this way. The first point I'm going to label as x sub 1, y sub 1. The second point I'm going to label as x sub 2, y sub 2. Really, these subscripts are just me labeling the first point versus the second point. So the subscript of 1 means it corresponds to the first xy pair, which for us is -4, -4. The subscript 2 says they correspond to the second xy pair, which for us is 2, 5. All I have to do now is plug these numbers into the slope formula. So let's do it. All right, on the top, let's go to the top. It's telling me grab the y sub 2 number. Our y sub 2 number was a 5. So I'm going to put a 5 here. Now we need a subtraction sign. Now it's telling me go grab the y sub 1 number. Our y sub 1 number is a -4. So I'm going to be subtracting a -4. All right, let me go to the bottom of the fraction. The bottom, we need x sub 2. Our x sub 2 number was a 2 here. Then I need a subtraction sign. And now we need x sub 1. Our x sub 1 is a -4. Let me stop here for a second and just kind of summarize. When they give you 2 points like this, label the first point x1, y1. Label the second point x2, y2. Plug those numbers into this magic formula, and now you can calculate the slope. Anyone have a question on how we came up with these numbers to plug in here? All right, well, let's finish it up then. Now, reminder to you, when you subtract a negative number, subtracting a negative number really flips to be an addition. So I'm going to write the top as 5 plus 4. The bottom of the fraction, when you subtract a negative number on the bottom, it really flips to be addition. So I'm going to write as 2 plus 4. Well, it looks like we're ending up with 9 on top and 6 on the bottom. But I remember that usually we want to simplify fractions, so I'm looking for some number that'll evenly divide into 9 and 6. I think the number 3 would work, so I'm going to divide the top by 3 and divide the bottom by 3. On the top, 9 divided by 3 is 3. On the bottom, 6 divided by 3 is 2. So my answer is a slope of 3 over 2. And it is positive, which is what I was hoping for. So folks, please write this formula down somewhere. And, it makes sense that the y sub 2 minus y sub 1 should be on top. Because remember, slope is vertical change over horizontal change. And by you working out y sub 2 minus y sub 1, remember, y is a vertical distance. So y sub 2 minus y sub 1 really is calculating the vertical change. So that's why the y's are on top of the formula. The x's go on the bottom of this formula. Folks, should we do another example? Or is everyone kind of okay with this? Anyone want to do another example? Don't be shy. We could definitely do another one if. Okay. Folks, why don't we do one more and then we'll take a quick break and then we'll come back and talk about parallel perpendicular. Let's do one more here, which is slopes of horizontal and vertical. All right. Yep, Lily, I saw your message. Let's do that one in a second, Lily. All right, folks, let's work out these two examples. This will be more practice using that slope formula. Now, before we do this, I want to remind you about dividing by 0. If you have 0 divided by 12, notice here the 0 is on top. 0 divided by any number is 0. Does anyone remember what happens if you have a 0 on the bottom?
It becomes undefined.
Good. 15 divided by 0 is undefined. What that means is you're really not allowed to do this division. It doesn't really have any meaning to it. All right, so we're going to need that for this topic. So let's do part A here. Well, I'm going to label these points as x1, y1, x2, y2. Let's plug into the slope formula. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's plug in. Our y sub 2 number is -8. Our y sub 1 number is a 1. Let me go to the bottom of the fraction. Our x sub 2 number is a 2. Subtract the x sub 1 number is a 2. Uh-oh. On the bottom of this fraction, 2 subtract 2, that's a 0. The top, -8 subtract 1. Again, I'm thinking that my starting balance is -8 in my checking account. My wife wrote out a check for $1. That means the new balance is -9. But what about -9 divided by 0? Undefined. So I'm going to select this undefined answer choice for part A. Let's graph part A. We don't have to graph it, but let's graph it just for the fun of it. So 2, 1, that means go over 2 and up 1. So 2, 1 would be here. And 2, -8. 2, -8 would be down here. So this point is 2, 1. This point is 2, -8. Well, this line is a vertical line. Do you remember the slope of a vertical line is undefined? And that's what the slope formula told us, because the slope formula, we end up dividing by 0. All right, let's do part B. For part B, let's label this as x1, y1, and x2, y2. And let's plug into the slope formula, which is y2 minus y1 over x2 minus x1. All right, let's grab the y sub 2 value, which for us here is a 3. Subtract the y sub 1 value. That's also a 3. On the bottom, we need the x sub 2, that's -2. Subtract the x sub 1, which is a -9. Well, on the bottom of this fraction, I'm subtracting a negative. That flips to the addition, so that's going to be -2 plus 9. At the top of the fraction, 3 subtract 3 is a 0. So this is going to be 0 over 7. But 0 on top gets you the answer 0. So this answer is a 0. And if I was to graph this equation, these points very quickly, negative 9, 3 would be here somewhere. Negative 2, 3 would be here somewhere. Well, this line would be a horizontal line. And if you remember, a horizontal line has a slope of 0, which is what the slope formula told us. Okay? All right. Folks, so let's take care of two questions that came up. One question was dealing with parallel and perpendicular lines. And let's take a look at this topic, because this one seems to be causing a lot of trouble. So let's take a look at this one. I think, Lily, this might be the example you were talking about. Okay, so here's the setup on this. It says the equations of three lines are given to us. Line 1, line 2, and line 3. For each pair of lines, compare them and determine whether they're parallel, perpendicular, or neither. Well, before we jump into this, let's ask ourselves, what does it mean to have parallel lines, perpendicular lines, or neither? Well, parallel lines means, here's parallel lines. Parallel lines means the two lines are going to always be the exact same distance apart, kind of like railroad tracks. So these are parallel lines. The two lines are always equally spaced from each other. Well, if you think about it, parallel lines are going to have the same slopes. Because for the red line, let's say the slope is 5. But the blue line really has the same steepness. So the slope would be 5 also. So parallel lines have the same slope. All right, let's go to perpendicular lines. What does that mean? Perpendicular line means the two lines intersect at right angles. This is kind of like, this is kind of like an intersection in a roadway. So these two lines are intersecting at a right angle. That makes these lines perpendicular. Like, for example, think about this as being Main Street, and this is like Elm Street or something like that. All right, well, here's how you can tell perpendicular lines. You look at the slopes. The slopes have to be different signs. Let me draw this example a little differently to make it a little easier to. Let me draw the lines looking like this. Let's say here is one line, and here is the other line. Sometimes you see a little square put here. That means these lines are meeting at a right angle. Well, the slopes have to be opposite signs. You can kind of see that from my diagram because this brown line would have a negative slope. It's going downhill. And the green line has a positive slope because it's going uphill. And the slopes also must be reciprocals of each other. Reciprocal means a fraction flipped upside down from itself. So let me give you some examples. 3 over 4, comma, negative 4 over 3. If this was the slope of line 1, and this was the slope of line 2, these lines would be perpendicular. Do you notice how they're negatives of each other? They're opposite signs, and they're also flipped upside down. This first slope is 3 over 4, but this slope over here is 4 over 3. So that means these lines would be perpendicular. All right, so the key to this problem is we have to find the slope of each line and then compare the slopes. If the slopes have the same value, let's say the slope of one line was 5, the slope of the other line was 5, that would tell you the lines are parallel. If you compare the slopes and their opposite signs and reciprocals, that would tell you the lines are perpendicular. If neither of these scenarios exist, then you're going to answer neither. All right, let's do it for this example. First, we need to find the slope of each line. So I'm going to make up a little table here where we can document this. Where can I do this? Maybe I'll do this down here on the bottom. Let me erase this for a second. So let me write my example here. I had 3 over 4 and negative 4 over 3 as the example. So here's what we're going to do. Line 1, we're going to write down the slope. Line 2 and line 3. Once we have this table filled out, we'll be able to answer this question. All right. Let's go to line 3 because that's an easy slope. I'm looking at line 3 here. Well, I want to know the slope. Let me compare to the famous y equals mx plus b. Can anyone comment, what is the slope for line 3? Yep, at least says negative 5 over 2. Yeah, because the m here is matching up to negative 5 over 2. So let me write that here. Negative 5 over 2. That's the slope for line 3. All right, let's go to line 2. Well, line 2 is giving me the equation 2y equals negative 5x plus 5. But before I can use y equal mx plus b, I've got to get this equation to have just y on the left-hand side. I can't have 2y. I need just y on the left-hand side. So what I'm going to do is divide both sides of this equation by 2. Now, when you do this, it's important that you divide every expression on the right side by 2 like this. So really, I'm dividing every expression on the left side by 2, every expression on the right side. All right, this 2 cancels out with that 2. So it looks like I'm left here with y equals negative 5 over 2x plus 5 over 2. Well, if I compare this to y equal mx plus b, I'm seeing the slope again matches up to negative 5 over 2. So for line 2, the slope is negative 5 over 2. All right, one more line to go. Let's go to line 1. Line 1 is going to be a little tricky because we have to get this equation solved for y. Remember, we want these equations to look like y equals mx plus b. This way we can figure out the slope. Let me start out here. Let me write this equation. 4x plus 10y equals 8. I know I want to get y isolated on the left side. Let me get rid of that 4x to start with. So I'm going to subtract 4x from both sides. All right, what that's going to leave me is 10y Now, on the right-hand side, I'm going to put this negative 4x first. So I'm going to write this as negative 4x plus 8. The reason I wrote it that way is I want this to look like y equal mx plus b. So I wanted to put the x expression in front. All right, well, I still want to get y by itself. Let me divide both sides by 10. All right, that 10 cancels out. Looks like we're left with y equals negative 4 over 10x plus 8 over 10. So the slope for line 1 is negative 4 over 10. But I know I want to simplify slopes. Let me divide the top and the bottom by 2. So this is going to be negative 2 over 5. All right. After all that work, I think we're ready to do the comparison. The first question they're asking us is to compare line 1 and line 2. So I want to compare these slopes here. First, are the slopes equal? No. Line 1 is negative 2 over 5. Line 2 is negative 5 over 2. They're not the same. That means the lines are not parallel. So not parallel. Are they perpendicular? Well, to be perpendicular, they have to have different signs. But they have the same sign. Both the slopes are negative. That means they can't be perpendicular. So that must mean the answer here is a neither. All right, let me move to the next comparison. So next, I'm going to move here to line 1 and line 3. Well, that means I'm going to be comparing this slope and this slope. Are they the same? No, they're not the same slopes. Are they opposite signs? No, they're not. So again, this is going to be not parallel, not perpendicular. It's going to be neither. All right, let's do the last comparison. The last comparison is comparing line 2 and line 3. So we want to compare these bottom 2 rows here. Well, I'm noticing they're the same slope here. Negative 5 over 2, negative 5 over 2. So they have the same slopes. Well, if they have the same slopes, that means the lines are parallel. So folks, this topic is a bit tricky because you have to do some algebra work first to figure out the slope of each line. And then you have to compare the slopes for the 2 lines you're interested in. If the slopes are the same, you know the lines are parallel. If the slopes are opposite signs and reciprocals, like 3 over 4 and negative 4 over 3, that would tell you the lines are perpendicular. Folks, any questions on this example here? This one is a little complicated. All right. Let's see, we have a little bit of time left. Let's go. There was one topic I think that Lily asked about, which was writing the equation of a line in slope-intercept form, given a point, given a slope and a point. Let's look at this one. All right. Now, it turns out when they ask you to write the equation of a line, there's 2 options. If you know the slope and the y-intercept, you can write the equation as y equals mx plus b. Because you'll know m, the slope, and you'll know the y-intercept b, so you could just plug in to y equal mx plus b. But what if you don't know the y-intercept? Because a lot of times you might not know the y-intercept. Well, there's another format. You can use what's called the point slope form. That looks like this. Y minus y sub 1 equals m x minus x sub 1. So this equation is when you know a point and you know the slope. Folks, these two equations are equations to write down on a summary sheet. Let me look at this example. It says a line passes through a point and they give me a slope. In this example, I don't know anything about the y-intercept. They're not telling me the y-intercept at all. That means I'm not going to use y equal mx plus b. So I'm not going to use this equation. But I do know a point and I do know the slope. Well, that's exactly when to use the point slope formula. So let's plug in here. Here's the equation. It's y minus y1 equals mx minus x1. Let me label the point they gave us as x sub 1, y sub 1. All right, let me go plug in. Y minus y sub 1. But our y sub 1 number is a 3. All right, now I need the slope m. They gave that to us as 5 over 4. In parentheses back here, we have x minus x sub 1. Our x sub 1 is a negative 8, so minus a negative 8. All right, let me clean this up a little bit because back here in the parentheses, I'm subtracting a negative. But whenever you subtract a negative, it flips to the addition. So this is going to be y subtract 3 equals 5 over 4x plus 8. But now I'm not done yet because they said write the equation in slope-intercept form. So they want the equation looking like y equal mx plus b. So let me clean this up a little bit because I want to get y by itself on the left-hand side. Well, let me get rid of these parentheses to start with. I'm going to take this 5 over 4 and let it multiply by x. So that's going to be 5 over 4x. Now I'm going to let this 5 over 4 multiply the 8. 5 over 4 multiplies 8. All right, let me clean this up a little bit. Back here, I'm noticing there's an 8 on top and a 4 on the bottom. Well, really, that's like 8 divided by 4. That's a 2. So I have y minus 3 equals 5 over 4x plus 5 times 2. Now, where is this 2 coming from? Well, I noticed there was an 8 on top and a 4 on the bottom. That's really like 8 divided by 4, which is a 2. But back here, 5 times 2 is 10. So here's what we have. Y subtract 3 equals 5 over 4x plus 10. Finally, one last step. I want to get y by itself. That means I should get rid of the subtraction of 3. I'm going to add 3. Got to do that on both sides. Here's my final answer. Y equals 5 over 4x plus 13. This is in slope-intercept form because we have the y all by itself on the left-hand side. So folks, the key to this problem was starting out with this equation, y minus y1 equals mx minus x1. This goes by the fancy name of the point slope form of an equation. The reason they call it that is you use this when you know a point and when you know the slope. All right, folks, I think we are out of time. Thanks for your patience. Folks, anyone have any questions to wrap up for today?
Thank you, Professor. You actually helped me understand a lot of this stuff. I appreciate it.
Excellent. Good. Folks, remember you have tutoring help if you need tutoring help. Please remember, spend time in Alex. That's the key. Email me if I can help or use that Ask My Teacher button in Alex. All right. Thanks, everyone. I'll see you next Tuesday. And have a good day today, folks. I'm going to stick around if anyone has a question.
Great. Thank you.
Thanks, Lily.
Have a good day, Professor.
Thank you. You too. Folks, anyone have any questions? Lorianne, yes. I'm going to send out the recording later this morning. It takes about a half hour or so for the recording to be available. But then I send out an email with the link. All right, folks, if there are no questions, I will close out. Thanks, everyone, for joining today.